In this lesson, we're going to start the discussion about area transformation. The concept of area transformation is very key when we want to draw two figures that have got equivalent area but are different. The first figure you might be required to draw can be any of the figures that we've learned how to draw. It can be a triangle, it can be a quadrilateral, it can be a pentagon, or it can be just some irregular shape that has been given to you that you are required to transform into another type of figure. This figure can be a triangle, a rectangle, or a square. Usually these three are your goals when you're doing area transformation. For example, we can have a triangle which has got a particular base and height. After you construct this triangle, you might be asked to transform it into a rectangle. Now, when you do an area transformation, one thing you always notice is that the second figure that you will draw, or the figure that you are required to draw, will have the equivalent area to the first figure that you drew. Here we can see by doing some mathematics, the area of the triangle is half the base, so half 10 centimeters, which is 5 multiplied by our height. So the area of this triangle is 20 square centimeters. Now, if you look at the rectangle on screen also, you will notice it also has the same area. We won't be doing this procedure mathematically, however, we'll be using geometrical construction methods to convert the triangle into the rectangle. We'll begin discussing types of transformations that are usually referred to as the fundamental area transformations. There are two of them. The first one is when we convert a triangle to a rectangle, then a rectangle to a square. I like referring to them as fundamental area transformations because they are always in a specific order. Let's say you've been given a pentagon that you need to transform into a square. The first thing you need to do is convert that pentagon to a triangle so that you can be able to convert the triangle into a rectangle, then the rectangle into a square. You can't move from the pentagon and directly go to the square by just one transformation. You always need to get the triangle, rectangle, and then the square. It's interesting that if you look at the word transform, we've got T, R, and S. So you should remember the order in which these transformations are done. The triangle into the rectangle, then into the square. Earlier in this video, we looked at how a triangle is converted into a rectangle. The procedure is very simple. We will have to construct that triangle that has been given of a particular base and a height. Then to make it into a rectangle of the same area, you notice we're just going to divide the altitude, which is the height. That height will be divided by 2. You must note that the base of the triangle is kept constant. It doesn't matter where this top vertex is, whether it's on top here or it's in the middle, as long as you get the perpendicular distance from the base to the top vertex there, you're going to have a height. If you divide that distance by 2, having h over 2, the rectangle that you form using your base and that new height is going to be giving you a rectangle of equivalent area. Now, for a rectangle to a square, there is some process where we'll draw some arcs and then we'll be able to get our square. The process is not very difficult. If you can remember this simple figure, you will be able to remember how to transform your rectangle into a square. That means for fundamental area transformations, remember that to convert your triangle to a rectangle, you will be dividing the distance of your height or the altitude by 2, while for a rectangle to a square, you need some arcs that will enable you to get the square. After you're comfortable with the fundamental area transformations, you now need to understand how quadrilateral area transformations are done. On screen, I'm going to use a trapezium to explain the concept. When we have a trapezium that has been constructed like this, the first thing we'll have to do is extend our base on one of the sides. Here I'm extending the left side. After we make that extension, we're going to join two vertices of this figure that we have. It can be a trapezium like this or any quadrilateral. So if we join this vertex and this other one here, you notice we form kind of a triangle. This is what you should be looking for. The two vertices that you join should form a triangle with two sides of the figure that you want to transform. After that, we're going to draw a parallel line to this orange line. This parallel line can be to any of the other vertices. It's best that you use a vertex that is related to the two vertices that you have joined. You can see this vertex is joined to that vertex where we slid our parallel line. So is it also related to this vertex where we joined. Now after we have done this, we're going to draw a line from this point up to this point. So we just join these 2 points with a straight line. After we do that, we now have carried out an area transformation that has made this quadrilateral into a triangle. The required triangle that we're looking at is this one here, the dashed line there, the dashed line there, and all the way up to this vertex and back to the first point where we started from. Now you might be wondering why we take this approach. There's a mathematical understanding of why we take all these parallel lines and everything. First and foremost, I would like you to appreciate that we have a triangle that I talked about. That area is the one we are working with, and that area is going to be equivalent to this area in this region. How? Let's just look at how the mathematics plays out. After we draw a parallel line to this first orange line, what you notice is this. The area here will be equal to this second area. So if the green area, which is area 1, is x, it means the second area, which is in blue, is also x. Therefore, if we add area 1 and area 2, we have 2x, meaning this whole green shaded area is representing 2x. Immediately we draw a line in the middle of this shape. It's basically like cutting our area in half. For some shapes that we'll draw using this principle, it will not always look like it's been cut in half, but for this example you can kind of see we're cutting it in half, and therefore the area at the top here is the same as the area at the bottom. So if we were to shade this area, we can also agree that this shaded area is also x. Now what this brings about is this interesting concept. If the first area that we shaded as green is x, and now this area that we're just from shading is x, it means we've been able to convert our trapezium, which had this shape as you can see, into a triangle. You notice the area in this region is not touched, so this area is not being altered, but this area in this region is the one that we are manipulating so that we can have a triangle. Just these few steps enable us to move from a quadrilateral to a triangle. And if we are required to make a square from this quadrilateral, it means on this triangle that we're just from making to have the area of the trapezium, we can do some transformations, the fundamental transformations, so that we can have a square. Now we can also talk about the polygon area transformations, where we'll be talking about polygons. We have regular polygons and irregular polygons. Both of these can be transformed to either a triangle, rectangle, or square. The procedure isn't so different from how we transform our quadrilaterals. So if we have a regular polygon which is 5-sided, we can extend one of the parts of the base like that. Then we will join two vertices. Whenever we join these two vertices, like I said, we always need to form a shape that looks like a triangle. Notice the triangle is being formed on this part where we have extended the line. After that, we'll draw a parallel line to this orange line at a vertex that is connected to any of these vertices that we joined by the orange line. you can see this vertex is connected to the vertex to which we've drawn our parallel line. After which we will join this point and this other point. The next part is joining the bottom part, this point to this point, and then we have our quadrilateral. Now when we're working with irregular polygons, we'll be still using the same concept. However, sometimes it might be a little bit strange to work with irregular polygons like this. The procedure is still the same. We'll join two vertices to form kind of a triangle. This setup is kind of weird because we are joining two vertices that are forming a triangle kind of outside our given figure. Most of the times here we had a line passing through the inside of the shape, but this time it's kind of outside. You don't need to worry. After you join those 2 points like that, you just slide this, draw a parallel line on another vertex which is connected to those two vertices that we used to draw our first line. Then, like we always do, we'll draw a line from this point to this point. After we do that, we have managed to make a polygon area transformation. You notice both of these polygons are 5-sided. One is a pentagon and the other is a reentrant pentagon. After we have these quadrilaterals, we can convert them to either a triangle, rectangle, or square. With this information really understood, you won't really get confused when you start actually drawing these different types of area transformations.